We are Group 6 and we will be presenting about destructible objects. First, I'll be presenting about the theory. Overview of destructible objects. Destructible objects refer to game objects that can be broken or damaged. For example, when an object breaks, it will be destroyed into many pieces. Main problem is creating destructible objects. The challenge in creating destructible objects lies in developing algorithms to stimulate object fractures and breakage patterns convincingly based on the material of the objects and the forces applied. There are math and physics involved behind object breaking. First, we have Newton's law of motion, material properties, stress and strain, and applied forces. For Newton's laws of motion, the first law states an object remains at rest or in uniform motion unless acted upon by an external force. The second law states F equals ma. The acceleration of an object is directly proportional to the net force acting on it and inversely proportional to its mass. F is the force applied, m is the mass of the object, and a is the acceleration. For the third law, for every action, there is an equal and opposite reaction. Based on the second law F equals ma, shooting a bullet that has high acceleration will result in higher force to a fragile object and will cause it to shatter as it is unable to withstand the force. Based on the third law, an object's internal forces resisting an applied force may be overcome, which causes the object to break. Next, material properties. The breaking of an object depends on its material properties such as elasticity, ductility, toughness, and hardness. Brittle materials tend to break suddenly without much deformation. Ductile materials deform before breaking. Next, we have stress and strain. Stress refers to the internal resistance of a material to an external force applied per unit area. Stress is defined as force applied perpendicular to the cross-sectional area of the material. If the stress exceeds the material strength, it undergoes strain. Strain refers to the deformation or change in shape of material in response to stress. There are tensile stress, compressive stress, shear stress. Different materials have different stress-strain relationships which determine their breaking point. This is the stress-strain graph. Lastly, we have applied forces. When two objects come into contact, forces are exerted based on their relative velocities, masses, and material properties. When an object explodes, it generates high-intensity forces which causes the object to rupture, fragment, or deform. To sum it up, there are many physics and math behind objects breaking or destroying. They include the 3 Newton laws of motion, the material and properties of the object, stress and strain relationship, which can determine the object breaking point, and lastly, applied forces, which will determine how an object breaks. Now I will be talking about my Unity implementation. For my Unity implementation, I created a character that can shoot bullets to hit a wooden wall and a concrete wall. After hitting the wall a few times, the wooden wall will break and it will make a sound. And same for the concrete wall. Since it's concrete, it will take longer to be destroyed. So to do this, to create this, firstly, I created these prefabs, the destroyed walls and the undestroyed wall. For the destroyed wall, it is made out of many small fragments Same with the concrete one. For my script, this method will be called when the collision occurs. This checks if the bullet with the tag shoot over here collides with the wall. If it collides, it will reduce the HP, the health of the wall by the health of the wall can be set over here. For the wooden wall, it has 5 health. And for the stone wall, it has 10. If the health of the wall is 0, it will create a new instance of the destroyed game object at the same position and rotation as where the undestroyed wall is. And then after that, it will destroy the current wall. And it will play the destroy sound of the wall. Over here, this is to check if the audio clip and audio source is not null. If it's not, it will play the destruction sound. For my shooting script, this code here checks if the left mouse button is pressed. If it is pressed, it will create a new object, which is the bullet, at the same position and rotation of the camera. And this code over here sets the velocity of the object to 2000. The components I use are the box collider, the rigid body, and the audio source. I also face some challenges where when the wall is broken, the audio of the wall breaking does not play. But eventually, I found out that I had to get the sound over here in the destroyed wall for it to work.
Greetings, I'm Yenming and this is my Unity implementation. So for the overview, I use Unity's capabilities to cause an object to drop and break. I utilize Blender to create the shattering effect of the object and the object itself. I also use the C# script to give the object a destruction audio. So I started off with a plane, which I later made in a cube. So that's what I made in Blender. And next we have object destruction through self-factoring. So I enabled it through edit, preferences, I search here in the add-ons, self-factor, and that's what I ticked. And so the original plane, it remains after the self-factor happens. So I basically deleted it, so I'm left with the smaller parts instead of the larger block. And how do I do that? I select the object. Since it's shattered, I'll just try this one out. Okay, F3, self-fracture, and you get these properties. So, an alternative is to do it manually by cutting the plane into smaller pieces. Solidify. As I started off with a plane, I have to make it into a 3D object by increasing the thickness of the plane. So how I did that? Modifiers, add modifier, generates solidify, and the thickness can be adjusted. So this is how I made it thicker. So next up, export and import. So if I export it as a FBX file to separate the different parts, otherwise all these will be exported as one uh, if I use OBJ. And so I use an FBX file instead. I directly export it uh, into the wallet section. Sorry, it takes a while. So I exported it into the wall section of the Unity project folder, which we'll see later. An alternative would be to export elsewhere and then just drag and drop it in. So let's wait for Unity to start up. Spawn object. So this one's pretty straightforward. Just drag and drop the FPX and directly into the scene. But you can see that under the main folder, there's several different pieces instead of just one block. Instead of one entire block by itself. That's why I used the FBX instead of OBJ. So the collider, the ground uses a box collider since it's just a plane. It's just a simple plane. I just use a box collider. The different parts under the FBX folder, on the other hand, they're given mesh colliders. Every piece, and config is ticked for all of them to avoid holes in the collider, so they don't face for each other. And to make sure that the collision actually works flawlessly. So these actually allow the wall object to shatter upon hitting the ground and not have the pieces not face for it. Okay, so here we are. So under the wall, we have this object. So this is what I imported as an FX file from Blender, and rigid body. So let me just show you the collider. So under every one of them, it's every one of them is given mesh collider. So convex is tick. Yeah, the mesh, it's assigned rigid body. So all of them has used gravity tick, so the objects actually fall onto the ground. They're individually assigned with like the rigid body for each of the broken parts. And the planned approach is to have them fall into the ground and crack into pieces, which they do. And so collision detection remains as discrete since there's no need to use continuous since like the fall is not too quick. The texture, I downloaded a free texture from textures.com. One sec. So this is the texture. And next up we have tag object. So basically for the script later, I created the ground tag for this plane. So the collision actually happens when the object collides with the ground, and I basically need this tag later on for and wall collision sound script. So a script is created for parts of the wall, and let me just open it up. So this is the script for the sound. And opening it up, as you can see, give me a sec. It's loading up. So as you can see, there's this audio source, audio clip and stuff. So the script was created. This is for each part of the wall when they hit the ground. They make a noise. So basically, they play an audio. So in order for it to play only a single audio, that's where it gets interesting. So I used has played, so to mark if the audio has been played or not. So under conditions where the object collides with the ground and the audio has never been played before, it will play. Otherwise, the audio will still be marked as unplayed. And also at the bottom, audio source volume, it's set to 1F, which means that it's at its maximum volume. So the audio as a wall is split into different pieces when hitting ground. So it's assigned to different parts under the wall, uh, under the wall FBX folder instead of the main FBX itself. So it's like instead of fractured wall, I assign it to each and one of those cube cells. So the sounds actually come from each different pieces when they hit the ground. So audio clip is set to the same clip route as I only got one clip from another project. So I got it from the previous PGG project, and audio. This is basically the audio. So it's not actually too. It's not ideal, but as you can see, it's assigned to each and every piece. So that's why as they hit the ground, I know it sounds funny, but it works pretty well. And so the challenge. So one challenge is I encountered an error where the audio was not playing. So I experimented with different solutions such as changing the lines of codes, assigning audio source and script to different objects and more. So it ended up working when I assigned it separately to the parts of the wall, the cube cells instead of the main fractured wall folder itself. So if I assign it here, the whole thing didn't actually work. The sound didn't actually play. But if I assign them separately, audio source, the wall script, so yeah, as you can see, it's the same audio throughout, but different audio source. So that's how I fixed it. Another challenge is it's not too critical. I just followed incorrect instructions from tutorials on YouTube. So yeah, it's not. It just took up some time. So basically, I exported in a incorrect file, and overall, all Unity and 3D modeling software Blender must work hand in hand to achieve the best possible result for certain effects, such as this. So it's especially true for destructible objects that crumble into smaller pieces and small parts in an event. So in this case, it needs the best of both worlds: self-fracture or cut tool from Blender and rigid body from Unity. So with better audio and a bit of dust effect for certain situations, developers can achieve realism with this method. And thank you for your attention. These are the references.